Our final video about the 1918 influenza pandemic and some of the economic history work that's been done on it is going to actually take a very different approach than the previous two papers we talked about. So both Almond's paper and my paper were really thinking about these long-term consequences of pandemic exposure, right? So that negative health shock leading to health issues that are going to have long-term impacts, and also affecting things like educational investments, which are going to translate into long-run impacts on occupational standing and incomes. We're going to switch to now the short-term immediate impacts of the influenza pandemic. We're going to think about the mortality of the pandemic. And the reason I want to switch to this is because there's a really interesting way in which the mortality of the pandemic is tied to the economy, tied to economic activity, right? And also tied to socioeconomic status in interesting ways. So what we're going to focus on is the relationship between pollution and pandemic mortality in the case of the 1918 Spanish flu. So what I'm starting with here is a photo from 1948, so clearly not 1918, but I give you this photo because it's this really famous example of the problems we were facing with pollution in the early 20th century that came particularly from things like coal-burning plants. So this is the Donora Fog of 1948. That's a daytime photo. This is Donora, Pennsylvania. And this fog is a combination of kind of fog and smoke and particulate matter and pollution that was actually deadly, right? So people in this town, I think it was something like a 3-day fog, died from this, right? Pollution was that bad. Basically, we have industrialization taking place throughout the first half of the 20th century with no real environmental regulation whatsoever. This is before the Clean Air Act, before the Clean Water Act. And it's this type of pollution that's going to lead to those changes, and it's going to lead to federal oversight of the environment in the second half of the 20th century, right? So I bring this up to point out that in 1918, pollution's already pretty bad. We have a lot of factories, we have a lot of power plants that are running on coal, and that's leading to a substantial amount of pollution throughout the country. And that pollution actually impacts the way that the 1918 influenza pandemic translated into mortality. So what we're going to focus on here is a more recent paper than the previous two we just talked about. This is by Karen Clay and Josh Lewis and Edson Severnini on pollution, infectious disease, and mortality, using evidence from the 1918 Spanish flu. So, as I already mentioned, they're not worried about morbidity and long-run outcomes. Not that they're not worried about it, they're not focused on it. Okay? Instead, they're going to focus on the mortality exactly at the time of the pandemic. And the basic question they're asking in this paper is, did pollution exacerbate the death toll of the Spanish flu? So if you lived in an area with high pollution, right, is that area going to see higher mortality rates when the flu gets there? So that might seem obvious to you, it might seem intuitive to you, but if you take a second and think about it, it's really not clear how pollution and economic activity are going to be related to each other. Okay? Pollution, economic activity, and health. So this is a big question of how those things are correlated. And in most contexts, it's really hard to get a straight answer because we have lots of omitted variables, all right? And because we have lots of reverse causality. So these are kind of the econometric issues that pop up time and time again, and this is why economists tend to study this problem of how pollution and health are related, right? So pollution and health might sound purely like a public health question, purely like a biology question, something like that, right? But it's that kind of identification issue, the econometrics of it, that brings into the wheelhouse of economists. Okay? And that's what this Clay, Lewis, and Severnini paper is going to try to do. So let's kind of talk through that econometric problem really quickly. So I mentioned omitted variables, right? And I mentioned reverse causality. So if our basic question is, does worse environment lead to worse health outcomes? All right, does more pollution make health worse? Right? It seems like a simple question, but first let's think about the omitted variable problem. So think about where a factory is. Do you want to live next to that factory? Probably not. Almost certainly not if it emits a lot of pollution, right? And so what happens is that land is not desirable. Neighborhoods that are far away from the pollution are desirable. So who's going to live in the undesirable neighborhoods near the factory? It's going to be people that don't have the means to move into the more desirable neighborhoods, right? So you're going to have lower income individuals living near the factory. You're going to have higher income individuals living far from the factory. And so now if we say, does pollution from the factory impact health? The really simple approach would be say, oh, people that live near the factory have higher rates of asthma than people that live far away, or higher rates of some other, health problem. Okay, maybe that's due to the pollution, but maybe it's due to income, since we have this sorting that's related to pollution, but driven by income, right? Whether you can afford to move away from that pollution. And so we can't disentangle those two things. Is it the pollution causing the health problems, or is it the low income and all the other mechanisms associated with that causing the health problems, right? So that is the omitted variable problem. In this case, income is that omitted variable. So now let's think about the reverse causality issue, okay? So here we're thinking about, does pollution cause worse health, right? Well, maybe it does, right? But maybe worse health is actually about less economic activity, lower income, right? And so as you start to get higher incomes and that gives you higher health, right? That's actually going to lead to more pollution because it's that economic activity that generates the pollution. Okay, so not exactly reverse causality, but more just showing you that we might be driving things in the other direction, right? It's poor health at first because we don't have economic activity. When we do have economic activity, that solves the poor health problem, but then that creates the pollution, right? So in this case, it would look in the data like pollution's correlated with good health, that pollution leads to good health, but that's not what's happening, right? So why does the 1918 pandemic really help us here? Huh? Why is it going to help us get around these issues? So on the one hand, right, it's going to help us get around things because of the timing of it, right? It's going to be this one quick health shock. So that latter story I just told you about, okay, economic development tends to go side and side with more pollution. Here we're going to get a health shock that's very narrow in terms of its window, right? So it's not about broad overall changes in economic activity, right? We can basically hold the economic activity fixed and then say, all right, hit people with this health shock, what happens? All right. The other thing that's going to be useful about the pandemic is what I was specifically saying earlier about our complete lack of environmental regulation back in this time period, back around 1918. Okay. So this is a modern map, right? But actually it's still pretty correlated with the way power plants worked historically. Right? If you look at this map, this is showing you power plants by type of energy input. Okay, so all the blue ones here are hydroelectric plants, and so they're more prevalent in the Pacific Northwest, where you have rivers that are useful for hydroelectric. Okay, coal plants are really prevalent, unsurprisingly, in coal mining country here, and then through the Midwest. Right, those are the black circles. Right, and then you've also got natural gas and oil. All right, those plants less relevant historically. But kind of look at that distribution of coal plants here. Look at that distribution of hydroelectric plants, right? Those are relevant historically, okay? Those were our two primary ways of generating electricity if you're talking about 1918. And so you've got geographic differences in what you're using to generate your electricity. The hydropower is not going to generate anything near the smog and smoke and pollution that the coal plants do. Okay, so you can have similar levels of economic activity. You can have similar levels of electricity usage, right? Similar numbers of factories, but some areas are going to be more coal-powered. Some areas are going to be more hydro-powered, all right? And that means that for the same level of economic activity, right, some places are going to have more pollution than other places. And so that helps get us around, once again, that tie between economic activity and pollution. And is it pollution impacting health, or is it the economic activity impacting health, or some combination of all of that, right? So here we've got this shot of holding a lot of these things constant, by making comparisons across different cities in 1918, right? And using this sharp health shock of the 1918 pandemic, right? Combined with this variation in pollution driven by basically what types of power are you using, okay? So what they're going to do is say, all right, now let's use that variation across cities and see, do we see a different spike in mortality when the pandemic hits for cities that have a lot of pollution versus cities that have very little pollution? That's the basic idea here, okay? So here we go, right? Let's start with infant mortality. So if we start with infant mortality, this is the basic picture of what they see. There's your 1918 influenza pandemic, right? We know there's a big spike in mortality there. I showed you that in the first of these bonus week videos. So what happens though, when we look at high coal cities versus low coal cities, okay? So the spike you're seeing here is not the spike I showed you in the first video. The spike in the first video just said all mortality went up, okay? And also specifically like influenza and pneumonia mortality. What this spike here is talking about mortality in high coal cities relative to mortality in low coal cities. So if the pandemic had the same effect in both cities, we actually wouldn't see a spike on this graph because it's about the difference between them. If they both move up at the same time, the difference is still zero. This graph would still show zero. Instead, we see a spike for high coal relative to low coal. So that tells us the pandemic was having a disproportionate effect on those high coal cities, right? The cities that had a lot of pollution saw this big spike in mortality that was above and beyond the spike in mortality at low pollution cities from the pandemic, okay? So we can interpret that as pollution from the factories exacerbating the effects of the 1918 pandemic. This is also true when we look at medium coal level cities versus low coal. Okay, so like medium pollution cities versus low pollution cities. We still get that same spike, right? It's even more pronounced over here on the right where we're using more controls, right? So that brings us back to like a nice even zero here. So they can control for all the observable city characteristics they have, trying to eliminate as much omitted variable bias as we can, right? And that makes high coal and low coal cities look really similar leading up to the pandemic. And then you get this giant spike from the pandemic, okay? So that's even further evidence that it's not some unobserved difference between these cities that matter, right? With all their controls, they're getting pretty much no unobserved difference in mortality rates, okay? It's all about that pollution during the pandemic drives this big difference, okay? So what if we look at all age mortality? We get the same thing, right? So it's not just about infant mortality. You might think, okay, it's just about compromised immune systems or undeveloped immune systems, sort of poorly developed lungs at the time, all of that, right? No, it's at all ages we see that spike, okay? We see that pollution exacerbated the death toll of the pandemic, right? So it's another fascinating piece of economic history that teaches us a lesson about what to look for with COVID-19, right? So we might be worried, since COVID-19 is another thing that affects the respiratory system that's going to be potentially exacerbated by particulate matter in the air, that we might see similar problems of disproportionate impacts on areas that have lots of pollution. All right, so to leave on a slightly less pessimistic note, although it's hard to have many non-pessimistic things when we're talking pandemics, right? There's also a very interesting kind of flip side to this with COVID-19. So we've had to shut down our economy essentially, right? We've had to close a lot of businesses because of social distancing, because we don't have an effective treatment yet for COVID-19. So one silver lining to all of that is that we've actually seen big reductions in pollution. So this is a measure of pollution in the air from NASA. Right? This is March 2015 to 2019 average. Okay, so you can see, the New York area, very heavy pollution, right? Heavy pollution around Baltimore and Boston over here, right? So what happens in March 2020, we're in the middle of our pandemic now, and everybody's stuck in their houses, right? Well, pollution really dramatically goes down, right? So there are going to be sort of some compensating positive health effects of reduced pollution, right? That'll hopefully offset some of the negative health effects of the big economic downturn associated with COVID, right? So that's a big difference between COVID and the 1918 influenza pandemic. We don't see that big economic downturn, right? And that's a whole different story unto itself that we don't have time to get into. But if you want to think about the economic downturn from COVID and its economic history analog, it's not going to be the 1918 influenza pandemic. Sadly, it's going to be something more akin to the Great Depression, right? And so we need to go back to that econ history literature if we want to think about how is the economic downturn going to be affecting people in the long term, right? And there's lots of work out there doing just that, and I urge you to explore it if you've got the time. So that's it for our bonus week lectures. Wish I had chosen a slightly more cheery topic, but this seemed appropriate.